What if I told you that there's a secret apparatus that's about the size of your forearm that only requires some basic fab skills that you can implement into any exhaust system to make it sound dramatically better? We've been using this design in most of our popular exhaust systems for over a decade, and in today's video, we're going to let the cat out of the bag as to what gives our exhausts their secret sauce. But before we do that, it's that time again to self-reflect and see if what we're about to tell you might be worthy of a subscribe, a like, or even both. So hit those buttons and let's get into the nitty-gritty of exhaust design. All right, 2016 S65 W222 chassis, the long-bodied S-Class. Now, this car has the same derivative V12 that the Pagani Huayra has, twin turbo, making 621 horsepower. Now, our request we get a lot of the times is, why doesn't this car sound more like an exotic when they do the exhaust? We're gonna go over a few of those things and what we at FMU would do to improve upon that. But first, a caveat. Now, anytime you take an exhaust and stick it through a turbocharger, you're going to have some sound restriction going through that turbine in order to make the horsepower. So with that said, extracting a V12 sound ends up being a little bit more difficult. But on this car, the customer was looking for just that. I did some stuff to my exhaust. I'm not happy with how it sounds. I'm gonna take it to some professionals right away, putting this car up. What do we see here? We've got aluminized mild steel pipe on a close to a $200,000 sedan. And a big problem here, we go from a factory 3-inch down to a modified 2.5-inch. Although they were right on with the thought process of putting the X in here, the execution leaves a lot to be desired. The way the X merges, how it comes out to the crush bends, are all just gonna work in conjunction with an exhaust that already, from the factory, is a bit restrictive. Now, I've talked about our rule of thumb here at Exhaust Building, and I got some kickback online. Basically, an inch per 100 horsepower. Now, I'm not saying that's the optimal way of doing it. There's a much better calculation, but an inch per 100 horsepower will get you into the range where you're not fighting exhaust flow, and it's just a good rule of thumb. It's not the most optimal. But this at being at 3 inches for 600 horsepower shows that we're already underneath that, which means we probably could gain some power just by stepping up the exhaust diameter. So that's the goal here. And on top of that, the goal would also be to incorporate something that would increase the pitch while going through this area underneath the vehicle over the cross braces in order to get out to the rear mufflers. So that's the idea here. This just isn't gonna work. And like I said already, we have some areas where it's crush bent. It's not gonna produce a sound issue with the car that has a heavy muffler system on it. It's not gonna create a clean tone if you were to just, let's just say, cut the resonators out and cut the mufflers out. Any bend you put in there becomes a restriction. Airflow always wants the straightest, shortest path out of a vehicle in order to produce the highest flow. And if you step the size down, if you put a bend in there, if you lengthen the pipe, all of that will have an effect on its maximal flow. So our plan is to try to fit the largest diameter piping in here while getting out of the back of the car, incorporating an X pipe, and maybe incorporating some sort of megaphone in there to enhance the V12 sound. It's always more challenging than I put it, but we've done these cars before. We have excellent results on it. And our work speaks for itself when I say that we do extract a more exotic tone than a lot of the truckish exhaust systems out there. But we also, by fitting that 3.5 in there, can support upwards of 700 horsepower, which is really just a tune and some exhaust work away. And that's exactly what we're going to do on this thing. Even today, with easy access to CAD modeling and finite element analysis software, Creating a great sounding exhaust isn't a simple task. When it comes to making power, the biggest factor is rectifying undesired pressure waves within exhaust tubing. As a high temperature exhaust pulse travels through the pipe, they generate pressure waves that can impact the flow of hot gas as it exits and circulates back into the cylinder. These waves mess with how the gas flows in and out of the engine. The configuration, dimensions, and curvature of the exhaust manifold have an effect on these waves. Given that each exhaust runner differs in shape, curvature, and length, synchronizing these exhaust pulses facilitate a lower pressure zone for the subsequent firing order, which means it becomes problematic. Optimizing this is what I believe led to the gains that we saw on our Aventador 180° squared project. But in practice, unless it's a special edition or an exotic vehicle where all aspects of performance are aggregated into the high price, most manufacturers don't even bother. They simply create something cost-effective that does a decent job of directing the exhaust and meeting emissions within the constraints of the vehicle, as long as it's not an obvious detriment to performance. And if it is, well, that's what the aftermarket is here for. Building parts like turbo manifolds, headers, exhaust systems to maximize performance that the engineers weren't given the budget to extract. Now in an NA vehicle, exhaust pressure waves encounter another hurdle at the collector. Inadequate collector design can actually impede performance as Helmholtz frequency waves induce pressure fluctuations that push the exhaust upstream and back into the cylinder, hurting power. However, at different RPMs, these waves travel upstream and rebound off the exhaust valve and can actually aid in expelling more exhaust air, therefore enhancing horsepower. However, on a turbocharged car like this Benz, the process is changed. The effect is still a factor because the air is forced into the cylinder, but it becomes much smaller to increasing performance. What matters more now is the pressure and expansion against the turbine wheel. So timing these fluctuations has less of an improvement compared to optimizing the flow, velocity, and heat. What all that means is that on turbo cars, while both are beneficial, time for designing for flow yields bigger results than time spent optimizing for the pulses. You can already hear it. Yes, you can do both, but development is time. Time is money, and to spend weeks or months and materials to yield a 1% gain would be pretty disappointing. You need to focus on the big stuff. So now that you know the psychology of why exhaust designers do what they do, where does sound come into play? The short answer is it usually doesn't. The sound is always going to be first and foremost the result of the power plant used. You can't make a 3-cylinder Prius sound like a V10 Carrera GT. Sorry if you're here to do that and I burst your bubble, but it just won't happen. Manufacturers are tasked with making a vehicle that will sell, so they need motors to use to make power that consumers will buy. Once they've decided on that, they then have to fit that into a vehicle. So whether they use an existing power plant or built the engine for the chassis, or in some of the available hypercars, built the vehicle around the engine, it has to fit. So most of the time, the exhaust configurations are built after this fact, meaning that optimal exhaust design is not possible like it would be on an open-framed race car. But not only does that exhaust have to fit, but it has to meet regulations for emissions, sound levels, etc., etc. Oh, and did I mention it has to be for as low of a cost as possible to maximize profitability? How good the car can sound is usually the last thing addressed after all these requisites are met, and in some cases, it's not even a thought. Even then, they are usually only reevaluating if they think that the initial design will cause the consumers not to want to buy it. So that leaves an opening for guys like me. The aftermarket can spend the time and the resources massaging out what the manufacturers left on the table, building systems that unleash horsepower, make the car louder, sound better, and sometimes all three. And that's just what FMU has been doing for the past 16 years, building thousands of custom exhausts on a multitude of vehicles ranging from economy to exotic. Our experience with sound and performance is pretty unique, which brings us to the Megaphone, which looks exactly as it sounds. We first started experimenting with them on our infamous Gallardo exhausts 13 years ago, and through trial and error, we've gotten pretty good at using them to create unique sounding exhausts and massive horsepower gains. But how do they work, and what can you learn about using them on your vehicle? Well, traditionally, megaphones are used on performance naturally aspirated vehicles and motorcycles to aid in expanding air volume and projecting pressure waves upstream, facilitating the expulsion of exhaust gases. However, these pressure waves are only effective within a particular RPM range, aligning with peak horsepower RPM in exhaust theory. Of course, engine configurations vary significantly even in similar power plants. Even with access to someone else's dyno data, it may not offer much guidance. Disparate factors such as intake manifolds, camshafts, piston profiles, cylinder head port volumes, they all influence horsepower and torque outputs differently, which means different results for individuals looking to employ a megaphone. This all just really means that you need to experiment with numerous use iterations before discovering the optimal match for your engine. Exhaust harmonics present a formidable challenge, even for seasoned engineers, meaning builders like ourselves or even a DIYer would have to undertake painstaking trial and error. Identifying ideal megaphone configurations means that considering variations in length, size, angle, just to eke out that extra bit of horsepower. And when talking about using them in the constraints of a car, the challenge is even more difficult. It's crucial to understand that reverse megaphones aren't a plug-and-play power solution promising a 10% increase. Optimal results require meticulous tuning tailored to a specific power band. Unless you're committed to serious racing endeavors and willing to experiment with various prototypes, a straight pipe exhaust may suffice for street applications. So that's a lot of technical jargon, only to end up telling you that if you're looking to make power on your NA car, you're gonna have to try a bunch of things and repeatedly test, which might not be feasible without the use of a dyno like we have here at FMU. Bummer. All right, so now that we got all that information out of the way and you know how to use megaphones to make power on naturally aspirated cars, what about just trying to make your car sound a little better, maybe a little more exotic? Well, like I said, that process is gonna take a bit of work. It's not just a straight slap it on and see how it sounds. I suppose it could be, but we do things a little differently here at Fluid. So that's been done. We're happy with how the system turns out, but in our experience, and I'm sure you guys at home would probably agree, the S65 motor typically doesn't sound that exotic, even though it's actually used in an exotic car like the Pagani Huayra. So how do we get a more exotic tone out of the V12 that Mercedes uses that typically sounds truckish? Let's start at the front here. Like I said, we've got a megaphone. Now, when we're doing this, we want to try to fit the largest diameter opening megaphone that we can that's not going to stick down too far below the car and become an obstacle that will hit on things like speed bumps. We want to try to pack it up inside of the vehicle, and we want to get the length. The length is going to be important for us extracting the sound. It tends to pitch up the vehicle just a slight bit. Now, placement typically on a naturally aspirated car would help with power. Turbo cars, it's a little bit different. So because we're not really looking for power, we're looking for sound here, we can be a little bit more forgiving on the placement. But again, as I keep alluding to, it all depends on the constraints of the vehicle. We can't just make a straight pipe and run this back and forth. We're limited to the sections on where something like this would even fit. So looking here, we've got to navigate down from the turbos and get us this straight line. So our first option would be this section here. We could have fit the Megaphones in this section, and that's what we tried first. We put this on the car, we fab up roughly what we're looking for, and we start it up and we rev it. Because at the beginning you're not 100% sure how it's going to pan out as you move further down, you kind of got to play along as you go, paying attention to the noises it's making, pay attention to the pitches it's making, and continue on with the build. So basically, it's just trial and error of finding a location that'll take these, putting it up there, roughly. We're not trying to weld it in place yet. We do want to take care of any of the gaps before that, so we're not listening to a hiss or some sort of turbulence, but we are listening as we rev this up. This process is pretty painstaking, and it's partially why when we do these exhausts, they tend to be more expensive than other aftermarket off-the-shelf available systems. So put it here, wasn't thrilled with it, still sounded quite a bit truckish. I was figuring that we'd have to move it further back. The next section would have been here, which you could see the straight section where we had the placement of it. Again, listened. Notice that moving it further back, and you gotta be thinking of things like a organ at a church, right? The longer pipes have different octaves, different tones, different pitches than the shorter pipes. So that placement is going to dictate how that sounds. The further back you go, that changes the sound. And where you put the megaphone will also have an effect with the length of the pipe. So again, this is really just trial and error of us moving here, finally getting to here where we've got a good amount of room, coming back out and noticing, hey, I hear a little something. I hear a little something that sounds more like the Pagani Huayra, which if you look at some of their exhausts, what are they using on there? Megaphones. So this isn't some little random process. People are using it to do the same thing, to extract a higher pitch out of the systems. And again, this is something where performance kind of follows form. People started doing this to extract performance on naturally aspirated cars, but using this, you can affect how the vehicle sounds within your system, while at the same time fitting back and keeping that power gain. So really kind of liked the tone, what I was starting to hear there. We were kind of out of options. I'm usually not a big fan of running them all the way back. If I'm going to be running a megaphone in the system, we want to try to keep it out of the last section, because in that last section, you run into the potential of creating a very weird drone resonance. The further back you go with either a chambered muffler, just a big space that the exhaust pulses end up bouncing into, the greater the chance that you're going to run into a drone issue. So you want to close it back down before you get out there with some pipe, the pipe diameter of the system. That way you minimize the drone of that system. But with all that said, we ended up in this section. We got a pretty good length out of where the megaphones are placed, and we've got some of our old systems to compare the sounds of this car versus the old ones, and I think you're going to notice the difference. Now that I've let you guys onto our little secret and you know a lot more about megaphones, what do you think? Are you guys going to try to use one to enhance the sound of your ride? What started off as a turbo back exhaust and custom tune in search of more power has now turned into a whole list of other potential mods that we're going to be adding to this car because the customer heard our exhaust and was so excited by the sound. So you'll be seeing lots more of this car coming up here, so stay tuned. But as always, guys, make sure you like, subscribe, leave a comment about anything you might see, anything going on in the videos. And until next week,